Yes, it's recording. All right, exercise 3B, the second part after learning how to add and subtract, you need to learn how to multiply and divide fractions. I can teach you the how, and I'm going to teach you the how first. And then for those who are interested, I will teach you the why it works. Okay, why we do them, why is it different. But I know sometimes when I go into the why, sometimes I lose you or sometimes I confuse you even more. So today I'm just going to go straight to the hows. And then those who want to learn the whys, I'll explain the whys. Yeah? All right, so here we go. What do you need to know for multiplication just as a FYI on method? When you're multiplying fractions, it comes to just this acronym or thing that I normally teach students. I say top with, and fill it in, top. So you multiply top with top, and you multiply bottom with bottom. Very good, bot with bot, okay? So this is as memorizing as you just need to do. So if you see multiplication of fractions, you literally just multiply the two top numbers together and then the two bottom numbers together. And you get your answer, right? There is a problem with that technique though, which I'll show you in the next example. So yes, multiplying fractions, you just do top with top. So for this example 3 here, it'd be 2 times the 1 on the top. So 2 times the 1. And then on the bottom, it's 1 times the 2. And that's pretty straightforward in doing that. So top with top, bottom with bottom. So here, top with top, bottom with bottom. So most students will go, all right, I'm checked out now because I know how to do it and I can do the whole exercise, and they'll start doing the exercise, right? Yes, but there is a caveat. That's not the skill we want you to learn because that's too easy, right? That would have been done in primary school. The skill that we actually want you to learn is the next one I'm going to show you. Okay, so this one, if I simplify it, it gives you 2 times 1 is 2, 1 times 2 is 2, and then 2 divided by 2 is? 1. So when they say 2 over 2, that's the same thing as saying 2 divided 2, which is 1. Okay? That's not what I'm interested in. What I'm interested in, these type of problems. See, if we stuck with the theory that I just told you, top with top, bottom with bottom, this is what students will do. 25 times 18, don't write this down, and then 15 times 20. What's the problem already? Fraser. But just looking at this, if I asked you to solve this, what is the glaring, scary thing that you think most of the students in this class is going to face? Yeah, that's exactly it. That's intimidating. I will not expect, even myself, I can't be bothered doing this. I probably could do it quicker, just do 25 times 20 and then take away 50 because 18 is only 2 lots of 25 less than 20, so that's how I would have done it. But this is not something I expect you guys to do, get me? But this is what students will get into. They will do top with top, bottom with bottom, and they just stick through that through primary school. And it worked in primary school because they never give you numbers that big. And in fact, these aren't even that big numbers. These are actually smaller numbers out of all the fractions you could get. So the skill that I want to teach you at year 8 level is not top with top, bottom with bottom. Before you get there, the idea is to simplify the problem so you can do. Now to do that, it does require that your multiplication tables are strong. So you need to know factors and multiples. Factors is the key part to simplifying. Okay, and to know your factors, you have to know your times tables. So here's the technique. Instead of doing 25 times 18 and then 15 times 20, our goal now is to simplify any numbers we can see. Now, when I say any numbers, this is the tip I want you to take away. I want you to look for any top numbers that you can match with a bottom number. Okay, so I'll say it again. Match a top and bottom. Not top with top and not bottom with bottom. You've got to find a top number and a bottom number that has a common factor. Doesn't matter about the position. It could be 18 with a 15. It could be 25 with a 20. Doesn't matter which one. But we want to find 2 numbers, one on the top, one on the bottom, that has a common factor. Which 2 numbers can you already see? Let's go with, 25 and 15. That is 1. And there's many ways you can do it, okay? So it doesn't matter which way. You could have done 25 and 20 as well. You could have done 18 and 15. It actually doesn't matter. You just pick 2, one top, one bottom, that has a common factor. Now, what's common about 25 and 15? Fraser? Very good. They both have a common factor of 5. Okay? Now, this is what I mean when it depends on how strong your multiplication tables are. So knowing your 5 times tables, 15 and 25 have a common factor of 5. So how many 5 goes in 25 and how many 5 goes in 15? 5 and 3. Very good. So here we're going to change this number now. We're going to say 25 and 15 can become now 5 and 3. So I'm going to rewrite the fraction again. So I wrote my working out. Here's my fraction again. So now instead of 25, I have 5. It's being multiplied 2. Still 18 over here. Instead of 15, we've now crossed it off to be 3 and 20. And you want to simplify as much as you can. So still find another 2 numbers, one top, one bottom, as a common factor. Ryland. Yeah, I would too. But I'm trying to prove a point that it doesn't matter which one you do. Okay, so if you pick the biggest ones together, then the number of simplifying you have to do is shorter. But if you pick the wrong ones, not wrong ones, it just takes a few more steps. That's all. But the point is I'm trying to say no one can do wrong here. Every time you simplify, it is a win. It's so much better than doing 25 times 18 and 15 times 20. So if you've been ready to do this, go from 5 times 18 and 3 times 20, that's so much better. Yeah, so you're always winning if you're simplifying first. Okay, so here we go. Now let's say we've chosen this step. I can still simplify further. What 2 numbers can you see now? What are the 2 numbers? Let's go, Jay. 18 and 20. 18 and 20, or you could have done 18 and 3 or 5 and 20. It doesn't matter which one. Just pick one. Yeah, so if I pick 18 and 20, what's a common factor of 18 and 20? Let's go with, yes, Sam? 2. So we say, yep, common factor 2. And yeah, I don't think there's any other high common factor. So 2, they're both even. 4 doesn't go into 18. 9 goes in 18, but doesn't go in 20. So yeah, I do think 2 is the best one. So how many 2s in 18? 9. How many 2s in 20? 10. So I'm going to change this fraction now to still 5 here times now this becomes a 9. 3 is still there, but the 20 becomes now a 10. And that's a lot better, right? So 5 times 9 we can now do, and 3 times 10. But don't jump the gun and don't do top with top and bottom with bottom. I still want you to go as far as you can. Are there any other numbers? Because I can still see 2 more pairs that I can pair with. Which 2 pairs? Good. 5 and 10 have a common factor. They're both multiples of 5. So 5 fits in 5 and 5 fits in 10. But also, 9 and 3, 3 goes in 3 and 3 goes in 9. This is what I meant. The better your times tables are, the faster you can do these bits here. But let's take that approach. So I'm going to divide the 9s by 3s. And I'm going to change the color here. I'm going to divide 5s by 5s, so multiples of 5s. Okay, so then we say, all right, 5 into 5 goes once. How many 5s in 10? 2. So this crosses out to be 2. Now on to the 9s and 3s. How many 3s in 9? 3. So this becomes 3. And then how many 3s in 3? 1. So you can see now my fraction is 1 times 3 all over 1 times 2. Now, isn't that a lot easier just from this step here now? Whoops. Well, whoa, what's going on there? See what we've done there? Instead of doing the very first problem, instead of doing top with top, bottom with bottom, this question now is a lot easier. See, if I asked you from the beginning, like Fraser said, the numbers are too big. 25 times 18, 15 times 20, most people check out. That's not the skill we're trying to look at year 8. You can use a calculator too, but that's not what we're trying to do. We're trying to get you to do this skill. We're trying to get you to simplify early before you do top with top, bottom with bottom. Okay, so top with top with bottom, bottom. So if you do that, 1 times 3, that gives you 3 on the top. Bottom is 1 times 2. And that's your final answer. The answer to this question, if I said, what is 25 on 15 times 18 on 20? The answer is 3 over 2, which is 1.5. Okay, so that's a lot. That's the simplest form you can get to. You can write it as 1 1/2 as well. But that's what we want you to get to. And we don't want you to do it by doing 25 times 18 and 15 times 20. Okay, it doesn't matter which pairs you have chosen. The whole point is to get down to the last bit.
In tests, do you have to simplify? Do you have to simplify the fractions in tests?
Yes, as your final answer, yeah? Yeah. In your test, especially for year 12 exams, examiners have like thousands of kids that they mark end of year. So they only have one answer on their answer sheet. They don't have multiple answers. And because of that, if you don't get the simplest form, they will then cross it off and say you're wrong. They won't even go back and check if this is right or not. Because most of the time, by the time you get to year 12, this is assumed knowledge that you can do this already, and they just look at the answer, and it's a 1 mark. So that's why at junior levels, you're practicing to get your working out correct, and then your final answer, always try to get to the simplest form. That is like the gold standard. Okay, but usually when it comes to tests with you guys, I'm a bit more generous. I'm not as harsh like my year 12s. With you guys, if I see that you're almost there, I'll give you a mark for the method, but ideally this is the answer I would want. Okay. All right. Now for you to practice, just to practice that skill that I just wanted. Again, I gave you another one. So I wrote here, try this. You got 32 over 15 times 20 on 28. See, if you did top with top and bottom with bottom, it's crazy. It's too big. I want you to use the skill I just taught you. Break it down. Break it as far down as you can before you do top and top, bottom, bottom. See if you can get this answer. I'm going to pause the video. I'll give you, let's say it's 10:42. Let's give it 4 minutes. 4 minutes. Have a go with this one. See if you can. And it's recording again. Did you get your answer as 32 on 21 or 1 and 11 over 21? Hands up if you got it right. Well done. Good. Okay, there's a lot of ways to simplify it. I just chose 20 and 15, highest common factor is 5. So it became 4 and 3. Then 32 and 28, highest common factor is 4. 8 and 7. And then top to top, bottom to bottom. So 8 times 4, 32. 3 times 7, 21. Okay, so simplify. The better you can find highest common factor, the quicker you simplify it. Okay? All right. Copy that down if you haven't got it right, or if you weren't sure of the method. And then flip over the page. We're going to do division, and that's it for today. And again, if you want to know the whys, why this method works, I can teach you individually. Just let me know, and I'll explain it. All right, let's flip over the page. All right, here we go. Second skill for today, division. So, back in primary school, they were said, when we divide fractions, I know they say what we do is we change the fraction and then change the division to a multiplication sign. The reason why I generally don't like this method, and last year a kid told me this is how they learnt it from their primary school, they call it the KFC method. Hands up if you heard of that before. Oh, Mr. Rao. Okay, well, I was told by the year 8s and that was new to me, but if you guys remember, K was keep the first fraction, flip the second fraction, and then change the symbol. Okay, so keep the first one, keep it as 3/4, flip the second one so it becomes 5 on 1, and then C, change the division sign to a multiplication sign. So that's a memorizing process for you to go through. There's a real reason why we do that. If you want to know why, I can show it to you. It's over here. I can guide you through the proof to it. But today I'm just trying to show you the method. Okay, so let's take this example. If I wanted to teach you how to do 3/4 and we're dividing it by 1/5. Okay, so I'm dividing it by fifths. Not dividing by 5, I'm dividing by fifths. Okay, so I take 3/4 and I'm going to cut 1/5. How many 1/5 fit into 3/4 is what I'm asking. So the method is you flip the second fraction, keep the first one. So it becomes 3/4 times now 5/1. I've changed the division to times. And then because now it's times, if you've learnt how to do multiplications, then you can now do the division part here too. So 3 times the 5, 5 times the 1, and this now becomes 3 times 5, and 4 times 1 becomes 15 over 4. If you're wondering what the difference between the first step and the second step is, anyone see it? Why did I put in this step? What's different? Good. It's to help you, if you're wondering why I did that. I did it because, in addition, say it was 3/4 plus, say, 1/4. So the intermediate step is together as a fraction, you don't add 4 and 4. That's what most students do. They're the same type of fraction. I've got 3 of them plus another 1 of them. So I've got in total 4 of those quarters. See that? So that's 1 fraction. So here I usually then say to you to put 3 plus 1 to show that you only add the numerator. Why did I do it for this one? So that to show you, you do actually multiply the bottom together. So the top with top, bottom with bottom. That's what I'm trying to say there. And that's my final answer. Okay? Or you can leave your answer as changing improper to mixed fractions. How many 4s fit into 15 nicely? 3 wholes, remainder. 3, and it's out of 4 because you're currently working quarters. Okay, the type of fraction is quarters. So remainder 3 out of the 4. Okay? So that there should cover your second half of 3B. So you learnt how to multiply. If you know how to multiply, you know how to divide. There's only one small difference there. KFC is the method. Again, if you want to know the proof, I can show you the proof as to why we do KFC, why it actually works. Otherwise, if you're just learning fluency skills, then that's your fluency skill. Cool? One last caveat. On your very first page, I didn't mention about this, but I did talk to some individuals. When you're doing this question, mixed fraction, adding or subtracting, I know in the textbook they teach you a shortcut. They teach you to go 4, take away 2, and then they say do 1/5, take away 3/4. Yeah? I don't recommend that method, but in your textbook at the moment, all the questions will work, okay, in the shortcut method. This one, why don't I recommend it, is because in this good example here, 1/5, is that smaller or larger than 3/4? Smaller. 1/5 is about 0.2. Yeah, and then 3/4 is 0.75. So if you do 0.2 take away 0.75, you're going to get a positive or negative number? Negative. So where's that negative come from? You're going to have to subtract from the whole. It gets very confusing. So the ones that in your textbook, they've designed it so that it doesn't become negative. But what I'm trying to prove here is that if you did the textbook method, you're going to get it wrong. So the general advice I give to students, especially for the next exercise, 3C, don't do the textbook shortcut. You actually have to do it the long way. Convert them into improper. So this one I'll do 5 times 4 is 20. 20 plus 1 is 21 on 5. Take away 4 times 2 is 8. 8 plus 3, 11 on 4. And then now you work this one out like you normally would. If you do it that way in exercise 3C, you won't make a mistake. But if you do the shortcut, it works for exercise 3B. It won't work for exercise 3C. Okay, so shortcuts work only if you know what you're actually doing. But if you're just memorizing it, you will get it wrong. So my advice is mixed fractions, do it the long way if you can. Okay, otherwise in 3C you'll find some troubles. Okay, I'm going to stop the video there, and that's it. And put up your hand if you, after a while, if you want me to prove to you why division you do what you do, I'll come around and explain it to you. Otherwise, that's it for today.